Hello my friends and welcome back to another episode of Flutter Explained. Today we want to take a look on how the World Wide Web works and how the internet communicates. For that we want to first take a look into HTTP, how it works, what it is exactly. After that we want to have a look into request-response cycles. And last but not least we want to write our own HTTP files which will then make the requests to our servers. For that we will understand how the HTTP verbs are working and how we can send requests to our server without a browser. Alright, and now without further ado, let's get started. Some of you maybe remember already the video where I talked about how web servers in Dart are working, and I introduced you to a lot of stuff like how you create a web server in Dart, and we made some requests and got responses from the server. We made already a header part where we route what exactly we want to get back and things like that. But today I want to introduce you a bit more in detail what these things are, so that you understand and we can build on that knowledge further. Alright, HTTP stands for Hypertext Transfer Protocol and is one of the TCP protocols that defines how the web is communicating. So that means how a server and a client communicates. That means that you can exchange all kinds of data like videos, images, text, information, HTML, all of that, as long as both the server and the client understand how to work with these information types. That tells us some things, because HTTP has some three major important things to know. The first part is HTTP is stateless. That means usually if you make a request, a server gets the information, the connection stops. That is different to WebSockets, for example, which keeps the connection between the both. But now the connection stops, the server does something, and as soon as the server is ready with a response, it sends it back to the client. The second part I already mentioned. It is important to note that both the server and the client need to understand how to work with the data. So it doesn't work if the server does not understand that the client wants to send, for example, a video. Then the server does not know how to work with it. That usually happens if you have some file types that the server doesn't know. For example, .mov is not really known in the web, so it's more MP4 and things like that. So that is the idea behind. Alright, and the last part is that HTTP is stateless. That means that if you send a request, it has no prior knowledge about all the requests that have come before or will be sent afterwards. And that is very important because then you can build on that if everyone knows exactly how it works. But now we want to talk about the request-response cycle. Alright, welcome to the whiteboard again. So on the one side we have a client and on the other side we have a server. We know that both of them can communicate with HTTP. That is very important. And now we want that they both have the possibility to communicate via the internet, right? So we have the internet in general above everything. And these two are connected directly to the internet. So, and now these two want to communicate, and the client wants to send some information to the server, for example, save a specific file into the database. For that it would send a so-called request to the server, and this request contains some information and is usually structured always the same way. That is important for the HTTP protocol to work. First we will have a verb. So that will be, for example, if we save something in a database, for example, put. And with that, we define which action the server should do. Be careful, you can write these commands yourself. That means you could also use put to get some information and things like that. But you should always take a step back if you do something like that, because that is usually a very bad idea. After that, you have the IP address or the information where to receive the other site. So an IP address or URL. So we have the verb put and the IP or URL, Unified Resource Locator, which identifies where the information is stored for the server. Okay, and last but not least, we have the HTTP protocol, which defines how we want to communicate with the server. And that's amazing. With that, we have sent our first request to the server. And now the whole thing, the server does now something, right? It works. And after that, it sends something back and gets something like a response, right? And the response has also a defined way on how they should be structured. For example, if the server says, okay, I got your information, I saved it down, then it will probably respond with a 200, which is the HTTP code that we receive from the server. We will have a deeper look at that later. And this says us it is okay. So the status message is also containing. If we would get now data back, we would have also here some header and some body. So here is usually a header and a body and there. I will add you down in the video description below some information where you get more information about all the things. So if you want to get a specific header inside, it is all inside. And so there will be a link to MDN where the information are stored. Also, the request can have a header and a body, just to know. Okay, now that we have all that in mind and we know how it works, let's see how it works in practice and understand first which HTTP verbs there exist, because we will need them a lot. And after that, we create some examples in HTTP files. Let's get into it. You probably know exactly what time it is, right? Hit the like button, subscribe to our channel if you haven't yet, and if you feel especially spicy and you like that video, feel free to share it on Twitter. That would be amazing, it helps us tons. Thanks a lot, and now back to the video. In order to get started with HTTP files, we first have to install a plugin with VS Code called REST Client. In IntelliJ it is already built in, so you don't need that. As you can see, we work in the old project that we created in the web server tutorial, a link you will find up in the info box. And now with that, we created and started the server on port 8081. And now inside of our project, we will create a new folder called Tools. And inside of this folder, we want to create HTTP files. For example, example.htp. And the great thing about HTTP files is that you have everything in your client, you can check it in Git and share it with your team. So you don't need supportive tools like Postman or Insomnia, for example. And everything works exactly the same. The only difference is you have it in your IDE and it's text-based. You can also create variables and things like that, so check out the whole description of the REST client. It is really powerful, this HTTP files, and I highly recommend to use that. And now we send our request in the schema that we learned before, like get with the verb, and now we want to specify the protocol. For us it's HTTP, right? And there we can say now localhost and with the port that we have gotten. And now if we send this request by clicking here send request, you can see already down in the console that we get the information on the server side. And now here on the right side, you see the response that we receive. So we receive the protocol that we have sent. We get the number of the HTTP code, which is 200, okay. And then we get hello world. So what would happen if we send something to a resource that does not exist? Like for example, ASDF. Our server does not understand that. And let's see what happens if we send this request. We get a response back which says 404 not found. And here comes a question to you. Which is your favorite 404 page that you have ever seen? Please post it down or on Twitter. I really would like to see that. Okay, then in the meantime, you have the header that gives us more information about what we have sent and what we received. And then at the end, the information as a text like route not found. Okay, but is that only working for localhost, or can we also send it somewhere else, like for example google.com, and we can also make the request here. And as you can see here, we receive something else. We also receive 200 OK. Here we receive the content type text HTML, and we receive the HTML file which makes Google alive, right? So that is everything that the request works. So now you can create all the requests that you need in the get. You can have different posts, for example, post. We can also have delete, right? And depending on if this is implemented or not, we get different responses. So if I said that, we receive from Google, hey, 405, this method is not allowed. So what you try to do here is not allowed. Don't do that again. And you get more information in HTML style. Cool. So with all these information, we know now how a request response cycle works. There is one additional tip I want to give you. If you are in a browser, like for example Firefox, you can inspect the website that you are in and go to the network tab. And if you look into here, you can see if we reload the page, they are making a lot of these HTTP requests. And if you click off one of them, you can see the header, so the thing that we sent to the page. We can see what request we have sent and what we have got for a response back. So there are a lot of information, like for example, there's image somewhere, and we can see all the details how it is sent. You can also make the same thing happen inside of Flutter with the network tab. Okay, now to something critical. I know if you have the control over your server, you can do whatever you want. but try to be always in sync with the W3C consortium, because they provided the protocol, right? So they said how everything should be done. So for example, if we would change this get behavior here in the server, we would say, okay, instead of get, we make it as a post request, okay? So instead of a get, we use now post and send this request. Now we execute a get request with the post keyword, which will not only confuse you, but also your coworkers. Try to avoid that at all costs. The same thing is part of the response codes from the server. Because there are some response codes with the response code 200. Everything at 200 is okay. Server did something like created or thing. But if you would send now instead of 200 okay, a 401 and say, okay, here's the result, that would be also possible. So also try to avoid to create own HTTP response codes at all costs. There are some specific cases where it makes sense to create them, but they should be really, really rarely used. Okay, there are 9 different HTTP verbs out there to make your request to the server. But I will just go into the 4 most important ones. Get, which tells our server, please give me your information. That tells us, for example, if we want to get a website. You joined now to YouTube, so your browser probably made a get request to youtube.com. On the other side, we have put. So we want to save something in the database. For that we say put something in there. And with that we usually send also a body with the information that we want to save. Also there is the delete function. And delete, well, it states already delete something with a unique identifier from the server or from the database. It's a command, right? And last but not least, we have update, which is instead of put, which is always creating a new instance, it will update, try to find one existent information and will update this specific information. All right, and with this we have created HTTP. We understood how it works. We know now how the protocol works and how we can use it for our own web servers. The great thing is we made our HTTP files and we created some first requests. We received our first responses. We understood what HTTP verbs are and what HTTP response codes are. With that knowledge, you are now capable of creating your own web service and make your own API calls and create also your own API to deliver to other people. Okay, and with that, we have wrapped up everything and I hope you learned something today. Thanks for watching, hit the like button if you haven't yet, and now till the next time, bye!